Good.
So storing. So a good chunk of this category is about how you store your keys, obviously, but it's also about how you actually do the cryptographic operations.
Yeah.
And so something that I still see today, mind you, they're usually very old applications, but they're still in production today. I don't know, they haven't been tested or this part hasn't been seen. I don't know, but for whatever reason, I have seen personally some companies that are still using MD5. Some that are even using, they'll use, SHA-1, thinking, okay, well, it's not MD5, but these are, hashing algorithms that are just not considered to be secure anymore. And and I wanted to give a brief explanation. I think a lot of people who are listening to this podcast probably know, oh, MD5 is insecure, but I want to give a brief explanation as to why, because I think it's not always clear to everybody. And if this is redundant for you, apologies for this brief departure here, but when you okay, so there's two things that we talk about in this category. We talk about encryption and we talk about hashing, right? Encryption is where you use an algorithm to take data and make it unreadable, but then you also have a way to reverse that and decrypt that. Hashing is a one-way version of that. You take some string and you run some algorithm over it, and the same string in English, let's say the word apple, always turns into the same hash as long as you're using the same algorithm. So this way, when you log in and you add your password to the login screen and you hit enter, we don't look through the database to see if your password is there. We first hash your password and then look at that hash in the database and see if it matches the one that's already stored there. So there's all sorts of hashing algorithms, and the best hashing algorithm is one that is slow enough that it takes a long time to iterate through thousands of them, but is fast enough that it doesn't ruin your customer's experience when they're trying to log in or register. So generally, if it can take around a second or slightly less than a second, then you're in good shape, because what that means is that if an attacker wants to brute force your password, they're going to be running an algorithm that every time they have an iteration of a word, maybe they're using a big dictionary list of words to test against, or maybe they have a program that's coming up with random combinations of letters and numbers for them. But every time they want to test one, it takes almost a full second to hash it. So you can imagine for 1,000 passwords, that's going to be 1,000 seconds. And 1,000 passwords is not nearly enough to be able to guess somebody's password. So add to that also salting. So so I don't want to go too off the rails here, but salting is another way to make the password longer. It also makes it so that the hash is unique, so that two people both using the same password, if your password is Apple and somebody else's password is Apple, they'll produce two different hashes because they'll both have extra random strings appended to them. So the one thing it does is it makes the hashes unique. The other thing it does is that it makes the actual password much, much longer before it gets hashed.
Yeah, exactly.
So back to what I was actually wanting to say in the first place, which is that there's lots of different hashing algorithms, and that one of the early popular ones was called MD5. And at the time, it worked perfectly, right? It did exactly what I described. It took long enough that it didn't annoy anybody logging in, and it was short enough that it didn't annoy anyone logging in, and it took long enough that in order to brute force a password would take a long time. Over time, computers got faster and faster and faster. And this is what I have to explain to clients generally. Because computers are so much faster now, your phone, is 100 times faster than your computer was 15 years ago. So the MD5 algorithm for that reason basically is gone. It's deprecated. We don't use it anymore. So now there's lots of other ones that we recommend. We recommend bcrypt is still going strong as long as you use a lot of iterations of it. There's also scrypt and argon, and there's what else? PBKDF2.
Yeah.
Yeah.
decrypt.
And so these are the recommended. So when you look at ASVS, it'll say make sure that you're using a recommended hashing algorithm. That's a big part of it. It comes up in a bunch of different verifications. So usually, if you fail on one because you're using MD5, it'll usually mean you'll fail a bunch of other MD5 items. A bunch of other ASVS items that relate to that. And there's also things like make sure you're using a strong block mode, which is a thing that happens. It's part of your encryption or hashing. I guess encryption. Can you use do blocking modes?
Block mode is more like symmetric.
Yeah, I don't think that they
so,
apply to hashing.
No, but
Yeah.
for hashing, actually, as you told, like the hash function should have like multiple properties. Sometimes we ask in the interview questions, like they should be non-reversible. They should have avalanche effect. They should have like be collision resistant.
Yeah.
And also they should be deterministic. Like the avalanche effect also is like, it means that like a small change in the input results in significant change in the output. And also, as Jared told, in some cases we want to have like a hashing function that is quick to compute, but in other cases, such as like we have passwords, to avoid like such of those like attacks like brute forcing attack and like rainbow table attack, there are some solutions such as like using like key derivation or key stretching algorithms, or using salt or pepper. And there is a difference between like for salt, the thing is that you need to add a random data to the input and generate the hash, but there is a difference between salt and pepper. We store salt alongside the hash value, but for the pepper we don't store it, and we keep it secret, and we kind of in the back end we brute force that to find the appropriate hash. And other than that, like for Jared was talking about like encryption, and people, one of the ASVS items is to not use any insecure encryption algorithm. One of them is like first of all, like what is the difference between symmetric and asymmetric algorithms? Jared, you can go ahead and talk about that, and then I can talk about like why ECB is not secure.
Sure. Okay, so when we talk about encryption, there are generally two different types that we talk about. We talk about symmetric or asymmetric. If you've ever used a private key and a public key, that is asymmetric, because you both have different values that you're going to use to encrypt or decrypt a message or sign a message. Either sign and verify or encrypt and decrypt. Symmetric is where you both have the same key. It's when you share a password. That's symmetric encryption. The algorithms that are used for each have different strengths and weaknesses. Now, I'm not a math guy, but my understanding is that let's see if I can pass this test here. So symmetric algorithms are good for encrypting large amounts of data. Asymmetric encryptions are good for encrypting smaller amounts of data. And so generally, when you encrypt a larger thing with asymmetric encryption, under the hood, there's actually some symmetric encryption happening. And then I think the private key that gets produced is used to maybe encrypt the symmetric key or something like that. And it all happens under the hood. And this is why we have block modes, to break it into chunks. But it also covers things like the use of random number generators. Make sure that when you're creating a random number where the randomness actually matters, like for encryption or for when you don't want file names to conflict. That's not the word I'm looking for, but that is the meaning. Or when you don't want, when you want to make sure that user IDs are not sequential and random, you want to make sure that you're using proper random number generators. And generally speaking, whatever language you're working in, they will have two different random number generators. One that is just easy to use and called random, and then another one that's called usually secure random or something like that. So those are things to look out for.